Well, hello, grade 12s. We're going to take a look today at how to use those equations that we've been looking at and those models that we've been looking at to actually analyze some data and make some predictions in real life. So I'm just going to go over how to do Desmos with you today. We are going to be doing this for the next couple of days, so if you don't get it right away, we will be having more time to work on it. So just do what you can to try to understand what we're doing now and follow as we're going along. So this is regression practice. We saw the word regression in our homework a couple days ago, and I hadn't introduced that word, so we're going to tell you what it means right now. Regression means the models that we find. So I can use Desmos to find a best fit equation, aka a regression for the data set. So Desmos is going to find the best fit equation that goes on a data set, and that whole process is called finding a regression. So regression is the process of finding the best fit model for a data set. Desmos will fit whatever line you want to the data set. It's up to you to decide which fits better. And we've took three different models, or we've been talking about three different models, and here they are right here. So our three different models are linear, quadratic, and exponential. Now, this is the equation for linear, and we're going to be using this in Desmos, and I just want to point out to you that it's the same equation we've been using. This looks like y equals mx plus b. So in this particular version of the model, the a stands for the slope, which is also the rate of change. So we'll call that the ROC. And the b is the initial value, which we've been calling IV. So this is linear. The next one is quadratic, and in quadratic, this is the vertex. So the vertex is h comma k, and as we took yesterday, the h gives us our x-axis of symmetry, and the k gives us our max or min value. And lastly, we have the exponential. And for the exponential, the thing out front was our initial value, so IV. And this was what we multiplied by every time. That was our growth or decay factor slash decay factor. So we're going to be going along trying to get Desmos to decide for us or help us decide which one of these models actually fits a bunch of points that we're going to put on a graph together. So let's take a look. Our first example says, determine the model that best fits the data in this table, where X is the number of years since 1921 and Y is the population of British Columbia in millions. Okay, the first thing I'm going to tell you is that we're never going to put in 1921. We want to put in either we're going to let 1921 be year 0, and then this would be 10 years later would be year 10, and then this would be year 20, and so on and so forth. Or, since this is very close to being, 21 is reasonably close to 0, we could actually just let this be year 21. We're going to just take off the 19. Year 31, take off that 19. This is year 41, and so on and so forth. This is going to be our X values. That's our input values. And the population of British Columbia in millions, so this is 0.52 million, and you can see British Columbia doesn't even hit 1 million until 1951. And then in 1961, it's about a little more than 1.5 million, and so on and so forth. These are going to be our Y values. And what we're going to do is enter this into Desmos. So I have the step-by-step in your notes. And so I'm going to get you to open Desmos now. So you're going to need your phones. And if you just want to open Desmos, so it looks like this. We might have to pause the video while the class opens up Desmos. And the first thing we're going to do in Desmos is click this plus sign over in the corner. So I've got this arrow pointing here. We're going to click that plus sign, and then we're going to go to table, and it's going to insert this table in here. And that's where we're going to put our table of values that we had here. So then it says, enter your data set in the X and the Y column. Remember, the X list is the variable that is known first or set, so in this case, the year, and Y is the list of what is measured or calculated. So we know the year first, and then we counted the people in British Columbia. So this is what we've got. Our X list is what we know first, which is the year, and our Y list is what is counted or measured. So here's our X's and our Y's, and we're going to put that data set, and I just put it, this is what it's going to look like in Desmos. It came from over here. Our X's are 21, 31, 41, and then our population are here. This is what it's going to look like in Desmos, so we can do this to plug it into Desmos. So you're going to click on this now that we've entered the table, and we're going to put in 21. Now to do that, there's a little keyboard down here. We'll go 21, hit the enter button, which is the blue return key over here. 31, hit the enter button, and it's going to sense a pattern and put in 41. And since we do want 41, we can just keep hitting the pattern until we get up to 101, which was year 2001. It's not quite as easy for the Y's. We're going to actually have to enter those. So 0.52, enter. 0.69, enter. 0.82, enter. 1.17, enter. 1.63, enter. 2.18, enter. 2.82, enter. 3.37, enter. And 4.08, enter. So we've got all our data points put in there. Unfortunately, we can't see them on my table. Okay, so I've got all the data points in there. I can't see them on the table. So what I'm going to do over here, we're going to click on this little wrench key. And here we have the x-axis and the y-axis. So our x's here go from 21 to 100 in our 1, and our y's go from 0.52 to 4.08. So we have to make sure that we put in our smallest x's. So when I open up this wrench, the smallest x goes in here. So our smallest x is 21. So I'm going to put in 21. And then over here, we put in our biggest x, which is 101. Then we do the same thing for our y's. We're going to put the smallest y in here, which is 0.52. And we're going to put the biggest y in here, which is 4.08. And then you can see all the data points there. And you can scroll a little bit so that you can see them better. But if you put them in the wrench there, whoops, if you put them in the wrench for the smallest x and the biggest x and the smallest y and the biggest y, then you can actually see them, and then you can scroll for however you want. Okay. So that's got our points on there. So what do you think? Do those look linear, or is there a bit of curve to it? For me, I'm thinking it looks like there's a bit of a curve to it. But what we're going to do is put in those equations, and Desmos will put a curve over those points, and we'll see which one fits it better. So if I scroll down, actually if I go to the next page, we're going to enter these into Desmos. So back to Desmos. Have those open next to you. We're going to put those three equations in here. We're going to put the linear one in. And how you put that in, you press Y, and we need a 1. That 1 has to match what's in our table. See, our table has an X1 and a Y1. So our equation has to have a X1 and a Y1 in it. So we need Y1. Then we need that weird little tilde mark. It's not an equals, it's a tilde. And I'm going to show you where to find it. You got to press this ABC and press this tilde. And then go A, X, We need a 1 beside the x. The x's and y's always have to have a 1 beside it. And then plus b. We have to go back in here to get our b. So now that put a line on our screen. It put the best fit line it could find. And it's not a very good fit. So we're going to shut that off and see if a parabola fits it better. So we're going to go here and we're going to type in the parabola. The quadratic model was y1, y1, the little tilde, a bracket x1 minus, and we need an h, do the other bracket, and then we need a squared. This right here that has a squared, that's our squared button, and then plus k. We got to go back in here. There. Now that's looking better. That fits the model a little bit better. Okay. But maybe exponential will fit it even better. I don't know. Let's have a look. So we're going to shut that one off. And we're going to go back in here and we're going to put the exponential one on. And it's going to fit one of those exponential curves to it. So it's going to go y1, little tilde, a, then we need a bracket, and then a b. And remember, in exponential, our exponent is an x. So we have to use this a to the b button here and then put an x in there. And the x needs a 1 beside it. And it fits an exponential curve to our graph. I don't know, was that as, let's put them both on at once. Take off the exponential. Ooh, I'd say the quadratic one fits it better. It's looking pretty quadratic. Okay, so you can turn these on and off by pressing these over here, turning them on and off to see which ones fit. That linear, we're going to ignore the linear because it definitely doesn't fit. But I'm liking the quadratic. Okay, so this is the model that we want. Now we have to see what the heck this is telling us. So what this is telling us on here, this is telling us what the parameters are for A, H, and K. So it's just telling us numbers to fill in there. So if I'm going to fill in the numbers on here, and I'm just going to do it on all of these models. So for this model here, this is the linear, I would write y equals, and instead of this a, I'm going to write this, 0.045, and then we need an x, and then we need our b, minus 0.854. I'm going to go down to the next one. Let's fill this one in here. This was our model that we liked. And I'm going to write y equals, instead of the a in this model, I'm going to write 0.0004 bracket x minus, instead of h, I'm going to put 6.49 squared, and plus 0.4022. And then down here for our exponential, I'm going to put y equals, instead of the a, we're going to put this that's down here, 0.362. The b is going to be 1.02, and we need an x up top here. So those are our 3 models that our calculator gave us. Now, I do have to warn you, if you're following along on your page, instead of just watching what I'm doing, these numbers won't match up. And I am actually going to give you a photocopy of the ones that do match up before. When I first did this, I made a mistake plugging it in, and we did not get the same numbers here. So you're not going to have the same numbers in your formula. I just noticed that when I was putting this video together. So I will give you a photocopy of this completed note. It's also going to be on Google Classroom. So these are our 3 formulas. And over here it says you can turn the regression on and off. So I'm just showing you the 3 different regressions for this particular model. And then if we go to this one, it says use your best fit formula. What is the population of British Columbia today? So remember, this was telling us what the population of British Columbia was for all of those different years. And when we filled it in for our X's, instead of 1921, we had just put in 21. And instead of 2001, we had put in 101. And so for this year, 2023, we need to put in 123. So this is our value of X that we're going to use, and this is our model that we're going to use. So let's write out our model. Y equals 0.000417, bracket X minus our H is 6.49079. We need a squared, and then we need our K, which is plus 0.402231. Now, instead of X, we're going to put in today. Today. Today we figured out in 2023, X equals 123. So here what we're figuring out is what our model predicts the population of British Columbia is going to be today in the millions. So we have to plug it in. 0.000417 bracket 123 minus 6.49079 squared plus 0.402231. That's going to use our model so that we can make a prediction, because that was the whole point of it. We were seeing which model predicted or which model fit our data the best so we could make a prediction. So I'm going to pull this up here. Now let's get rid of what's on there. And we're just going to plug that in. 0.000417 bracket 123 subtract 6.49079. Whoops, what happened there? Backspace. Let's get rid of a few things here. 6.49079. That looks better this time. End bracket squared plus 0.402231. And hit enter. So 6.06. 6.06. So what that means is the population of British Columbia today, the population of BC today is predicted to be 6.06 million. That's what that means. So if I go back to our very first slide here, if I were to put this year on here, in 2023, our model predicts that it's going to be 6.0, what was that, 6.03? I gotta check again. My memory's crappy. 6.06. So 6.06 million is what our model predicts. Okay. Now, this is what we're doing with this stuff. Again, we're going to be doing this for a couple of days. So if you didn't get this completely today, I want you to give it a try. We have some homework questions here. So this one here, you're going to enter this one in for your X, this one in for your Y. Practice turning on and off the 3 different formulas for Desmos and see what you can get. This one's actually telling you what model you want. We only want the quadratic. So that's the one that we just did, quadratic. Determine the maximum value of the regression. So you should be able to pick that out of the regression equation. So I want you to give this a try. Again, when I come back tomorrow, we'll have a better look at it. And I will also have a photocopy of the correct note for you because your examples here, once again, did not match what the first, when I did your examples, I put in some wrong numbers, so it did not match correctly. So we're going to leave it at that right now.